Hello, hello. Okay, so welcome back to the channel. And if you are new here, hit that subscribe button because we are learning cool stuff every day. So today is day two of our learning roadmap, and today's topic is networking. This is a part one of our networking basic series, and trust me, whether you are aiming for cybersecurity or just trying to level up, this is where it all begins. But before we begin, quick reminder, in day one, we covered the most important Kali Linux command that every beginner should know. If you miss it, go check that video. Link is in the description. And now in this video, we are gonna talk about what exactly is a network, why networking even matters, and some core concept that help you connect to the dots later. Okay. So this is just part one, and part two is coming real soon. And in that, we all go deeper into the types of networks, topologies, networking device, communication method, and many more. Okay, so grab a notebook if you are serious, and let's start breaking down the basics like a boss. Okay, so all right, guys. So here what we are gonna cover in today video. First is networking basics. Second is type of network, then topologies, followed by networking device, and then we all hit transmissions mode, and finally transmission media and a quick intro to digital transmission. Okay, so but let me be real with you. We are keeping this video short and crisp. I don't wanna drag this and waste your time. We are gonna break everything down in such a simple and chill way. You will honestly say, bro, itna easy tha kya ye? So grab a notebook if you want, or just sit back and chill. Let's make networking basic feel like a walk in the park. Okay, so let's go. Okay, so topic is first topic is my network. Okay, so what is network? Imagine you and your friend are in a group chat. You are constantly sharing memes, photos, voice notes, all in real time, which you want to share. But have you ever wondered how that data is moving between your phones? Okay, that's the power of your network. Suppose you have two computers. Now you want to send a file from one system to the other, or maybe share a printer between them. To do that, you connect both systems using either a cable or a wireless connection. Now scale that up, five computers, 10, maybe even 100, all connected, all communicate. That entire setup is called your computer. ओके सो मान लो आपके पास दो कंप्यूटर है ओके और आप चाहते हो कि एक सिस्टम से दूसरे को फाइल भेजो तो ऑब्वियसली आप दोनों सिस्टम को वायर या वाईफाई के थ्रू कनेक्ट करोगे तो ये जो आप कर रहे हो ये सब क्या है वो नेटवर्क है आप डाटा शेयर कर रहे हो फाइल शेयर कर रहे हो रिसोर्सेज शेयर कर रहे हो किसके थ्रू कर रहे हो नेटवर्क के थ्रू दैट इज कॉल्ड योर नेटवर्क that multiple devices connecting together sending and receiving data that's exactly what is a computer network okay so that is your network have got multiple system computers phone all in one place but how do they talk to each other and how do they share file internet or resources right that's where networking comes in okay it's not just about connecting device but it's about managing how data flow and how secure that connection is and how efficiently the communication happen now listen carefully network and networking are not just the same things imagine you are in office with five computers everyone needs to internet file sharing and access to the same printer so you connect them using either cable or wi-fi right so the moment they are connected and can communicate that setup is called your network but what is networking you use switches router assign ip addresses configure setting and makes sure everything work without error that entire setup process what is called that is called your networking. So next time someone asks what is the difference between network and networking, just tell them network is what you build and networking is how you build it. Okay. So देखो मेरा मेन मोटिव ना यही है कोई डाउट नहीं होना चाहिए आपको सारी चीज एक एक करके आपकी क्लियर होती जाए तो बेटर रहेगा नाउ सपोज दैट लेट्स से यू आर इन दिल्ली योर बेस्ट फ्रेंड इज chilling in London you send a WhatsApp message hey bro check this memes how is it within 2 seconds, your friend see it, laugh, reply with 10 laughing emojis. Now think, how did that message reach across the global in just 2 seconds? 2 seconds. Answer is your internet. It's not magic. It is a tag billions of devices talking to each other every second. Okay. But second language, the first workable prototype of internet. Okay. The US Department of Defense started a project called ARPANET. Okay, so ARPANET stands for Advanced Research Project Agency Network. Basically, scientists wanted computer to talk to each other. So they built the first ever computer network. It connecting just four computer in the beginning. Right. Yeah, the internet started as a military scientist experiment. Now it's run your Netflix, online classes, memes, and late night Google searches. Right. So that's called your internet. Now come to the next topic, that is your message or token. This is a important concept. So let's begin it. So what is message or token? Suppose we have five computers connected in a ring topology and they all want to send data over the same network, right? But here is the catch, only one computer can send data at a time. So how do we prevent all of them from sending simultaneously and causing a data collision, right? So that is where the token comes in. Why? Have a look here. A small data packet called a token keep calculating in the network. Because when a computer get the token, it check, do I have any data to send and any data to receive? If yes, it grab the token and send the data and then passes the token to the next computer. If not, it's simply passes the token forward. So that's all about our token. It's all about working in a form of request. So next topic is our peer-to-peer model or P2P model. Okay. So imagine you are at a party and instead of a DJ controlling all the music, everyone can play their own favorite song, right? So you want to share your music with your friend and they want to share their with you, right? So that exactly how the peer-to-peer model works. Okay. And you have a bunch of friends and each of you have a unique playlist instead of uploading your playlist to a central server. So you can just share it directly with each other. And if your friend want to song from your playlist, they can get it directly from your computers and vice versa. No middleman, just directly share. According to definition, in peer-to-peer or P2P model network, every computer can act as both client and server. This means each computer can share file directly with other computer without needing a central hub. That is called your peer-to-peer model. Okay. So now come to the next topic, that is called your client-server model. Okay. Okay, suppose you walk into a cafe and you go up to the counter and place your order, right? Maybe coffee and sandwich, or maybe your momos. Okay, so that counter represent as a server, and you placing the order. So you are a client. Okay, so you don't go to into the kitchen and make your own food, right? You simply tell the server what you need, and they handle the rest. They process your request, prepare your order, and hand it back to you, right? So that's exactly how the client server model work in networking. Okay. So in this model, the client is any your device like your computer, laptop, or maybe tablet. Okay. So that requires service or data, and the server is a more powerful system that wait for those, okay, and respond with the requirement information for resources. Suppose when you type a website URL into your browser, so your computer send a request over the internet to a web server, and the server then process your request and send back to the web page, which is display in your browser. That is all about your client server architecture. Okay, so now next topic is what is the difference between P2P and client server architecture. Okay. So next topic is peer-to-peer versus client server model. Okay. So imagine you are using a torrent app to download a movie, right? The app does not connect to a single central server. Instead, it connects you to other user, that is called your peer, who already have part of that movie file, right? You download small pieces from multiple peer at the same time, and while you are downloading, other can also download piece from you, right? So there is no central server, it's all direct sharing, user to user, no middleman, just a community of device working together. So that is called your peer-to-peer model. Okay. So what is client server? When you visit a website, your browser which act as a client, and it send a request to a web server. The server receive the request and process it and send the web page data back to your browser, and your browser then display the page for you. Okay, so in this setup the server does all the heavy lifted, and clients simply request and receive its all placing. Okay, an order at a restaurant, you just ask and the server bring it to your table. In peer-to-peer or P2P, all devices are equal and can communicate directly with each other without needing a central server, right? But in client server, in this there is a central server that provide resources or service to the client server. Okay, and second is P2P can act as both as client and server, but in client server, the client make request and the server respond to those requests. Okay, in peer-to-peer, suppose file sharing app like BitTorrent, where each user can download and upload file to or from other user. But in client server, a website where the client send a request to the server and the server send back to the web page. Okay, it's like your restaurant. Okay, so these are the different between your peer-to-peer and client server model. Okay. Okay, so in this network diagram, we are looking at a basic home or your office LAN setup. Okay, so the cloud on the left represent the ISP, that is Internet Service Provider, which give access to the internet, and the ISP has assigned a public IP address, that is 82.10.250.19. Okay, and this public IP address is used by the outside world to communicate with your home networks. Okay, and second is router. Okay, so router is connecting directly to the ISP. It has two IP address. The public IP address, what is uh, which one? Which here? Okay, so 82.10.250.19, and a private IP address, that is 192.168.0.1. Okay, this private IP is used to manage and your route traffic with the internal network. Okay, now let's look at the internal device connecting to the router. One is laptop, okay, and two desktop. One is printer, second is PlayStation, and last is smartphone. Okay, so a laptop is connected via Wi-Fi and has the IP address that is 192.168.0.101. Okay, and the smartphone is also on Wi-Fi with IP address 192.168.0.100. Okay, and two desktop, that is one and two. Okay, one has the IP address 192.168.102 using Ethernet cable, and the other has 192.168.1 sorry 192.168.0.104. Okay, it is also connect through Ethernet. Okay, and a printer is connected via Ethernet with IP address 192.168.0.11. And last is PlayStation is connecting over Ethernet uh, as as well with IP like 192.168.0.10. Okay, all these devices are assigned private IP address in the range of 192.168.0. Okay, these IP are not visible outside the network, right? Whenever a device want to access the internet, it send the request to the uh, send the request to the router, and the router uses NAT, that is network address translation. Okay, so to replace the private IP with the public IP before sending the request, when the response come back, the router send the data to the correct device using its private IP. That is 192.168.0.101, and second is 192.168.0.104. Right. So this setup allow multiple devices to share a single public IP while maintaining unique identity with the local network. Okay, so this is how a typically home or office network work using routers, private IP, and NAT. ठीक है, and NAT stand for network address translation. Okay, So come to the second module, that is network types. Okay, so in this module, we all learn about the different types of network. The major type include your PAN, LAN, WAN, WLAN, CAN, MAN, SAN, EPN, VPN. Okay, so each of these network is used in different scenarios depending on range, speed, and purpose. So let's start one by one, beginning with the smallest type. Okay, so first type is PAN. PAN stands for personal area network. Okay, so this is the most basic type of network, and it is used to connect a device that belong to a single person, and the range is very short, usually around 10 meter. Okay. So suppose that you are listening to music on your phone using Bluetooth earphone. Okay. So that is your pen. Okay. Or another example, imagine that your phone is connecting to your smartwatch and showing your step. That is also personal area network. And even when your laptop is connected to a wireless mouse or keyboard, it is also part of your band. Okay, so these connections happen in your personal space, like your pocket, your desk, or your backpack. It is small, fast, and made just for your own device to talk to each other. Okay, no cable needed, just Bluetooth or Wi-Fi, and direct does the job. Okay, so remember, if your device are talking to each other within arm reach, it's probably a personal area network. Okay, so that is a pen, and it's a smaller network you use every day. Okay, so okay, so second is your local area network. That is LAN. Okay, so it connect multiple devices like your computer, printer, and your phones within a small area like a room or house, uh, a school or an office. And the range is limited, but the speed is really fast. Okay, so local area network is usually wired using Ethernet cable, but it can also be a wireless. Okay, now imagine you are in your school and computer in computer lab. All the computer are connected to one central system, that is your local area network. Okay, so I hope you understand what is local area network and personal area network. Now come to the second point, that is your wide area network. Okay, so in wide area network, it connect device and network across your large geographical area like your cities, countries, or even continent. Okay, so it is the biggest type of network, way larger than local area network on metropolitan area network. Okay, so when are usually built using leased line, satellite, fiber optics, and public network like the internet. Okay, now imagine a company has office in New York, London, and Mumbai, and all those offices are connected to the same network to share file and data. So that is your wide area network. Okay. So in fact, the internet itself, yes, the whole internet is the largest example of your wide area network. Okay. Now come to the next topic, that is your WLAN, which is stand for wireless local area network. It's just like a regular local area network, but without any cable. Okay, so instead of Ethernet wire, it use wireless signal, usually Wi-Fi, to connect device in a small area like your room, your house, or an office. Okay, now suppose you are at home and your phone, laptop, smart TV, and your tablet are all connected to the same Wi-Fi. That is your wireless local area network. Okay, so I hope you understand what is wireless local area network. So next is campus area network. Okay, so what is campus area network? Okay, basically a campus area network connect multiple building with a limited area like your university uh, and your business campus or your military base. Basically, a bunch of land that is local area network connected together across a single campus, but it's bigger than a local area network, but smaller than a metropolitan area network. Okay, now suppose you are in a college, the library and the lab and your admin office, all and all classroom, they all have computer connected to the internet, but they don't each have their own network. They are all connected to one big campus network that is called your campus area network. Okay. So next is metropolitan area network. Okay. Now suppose all the college office and public service across an entire city all connected through one single high speed fiber network, that is your metropolitan area. Okay. Or imagine a city traffic light, police station and your emergency service all connected to one secure network, that is also your metropolitan area. Okay. Even when multiple branches of a bank with one city are connected together, you get it, that is your metropolitan area. Okay. It usually owned by government or large companies and is ruled for high speed communication across urban area. Okay. And it's connect multiple local area network and campus area network within a city or in a large town. Okay. So that is your metropolitan area. Now come to the next, that is your storage area network. Okay. Suppose a big company that deal with millions of data every day, like a bank, hospital, or data center. Okay, so all their important data like backup, customer information, medical reports, is stored on a huge storage server. Instead of saving everything on each individual uh, PC, they use a storage area network to connect all device to one central storage device. Okay, so now what is in definition? It is special type of network used to provide access to large amount of storage like hard drive, SSD, and storage server over a high speed network, and it's not made for browsing or emailing. It's designed purely for moving and managing data between computers and storage device. Okay, so that is your SAN, which means storage area network. So come to the next model, that is your network topologies. So what is network topology? Basically, network topology is a layout or structure of how devices like computer, printer, server are connected together in a network. Think of it like a map or blueprint showing how all the devices talk to each other. Okay, so why do we use network topology? Just like a city need road to connect houses, a network need topology to connect device. Okay, so choosing the right topology help in make communication efficient and fast, reduce data loss, simplify troubleshooting, save cost, improve network. Okay, and some common network topology like your bus, star, ring, mesh, tree. Okay, so what is bus topology? Imagine an old style office where one single cable run across the whole floor and every computer is connecting to that same cable. It's like a long power extension cord where everyone plug in their laptop. Okay. Uh, so bus topology was used in small office and classroom back in the day because it was cheap and easy to set up. But if that man cable broke, the whole network system goes down. Okay. Okay. So in bus topology, this is a picture of your bus topology. Every device, every system connected to a single line, single cable. Okay, bus topology was used in small office and classroom back in the day because it was cheap and easy to set up. But if that man cable, okay, this one, this man cable uh, broke, the whole network stopped working. Okay, imagine an old style office where one single cable run across the whole floor. Okay, and every computer is connected to that same cable. It's like a long power extension cord where everyone plug in their laptop, right? So this is your bus topology, and come to the next, that is your star topology. This is the most common setup in homes, school, and modern office because it's reliable. If one device stop working, the rest keep running. But the central router, this one, central router fail, every system goes fine. Okay. Suppose think about your home Wi-Fi network, your smartphone, laptop, tablet, all of them connect to one central router. That router is the hub in the middle. This setup is called your star topology. Okay. Now come to the next. That is your ring. Now, ring topology was used in metro rail network and early token ring, like your local area network. The problem is if one connection breaks, suppose this connection is break, the whole loop can fail unless you use a special version with redundancy. Okay. Uh, Suppose picture a group of office connected in a circular path. Each office send data to the next one, like passing a node around a round table. The messages keep going until it reaches the right person. Okay, so this is your ring topology, and second tree topology. Okay, so tree topology, this is used a large company and education institution where different department need their own local setup, but also need to stay connected to a central network, right? Think of a university where each department has its own small network like a star. Okay, so all those network are then connected to one main backbone network that link to one man backbone. Okay, network that link the whole campus together. It like a tree. Okay, you look this structure, sorry, diagram. It's like a tree. Okay, small branches joining a big trunk. Okay, this one. So this is your tree topology. And last is third last is mesh topology. Okay, so mesh topology is used in military network, disaster zones, and your smart city because it is very reliable. Even if some part go down, the rest of the network still work. Suppose smart home where you smart light, speaker, thermostat, and doorbell are all connected to each other directly, right? If one gives goes offline, data still find another route like Google Map finding a new path if they are static. Okay, so mesh topology work like the next model, that is your network devices. Okay, okay. So in this model, we cover what is NIC card, hub, switch, router, repeater, modem, bridge, gateway, access point, server. Okay, so these are the basic type of network devices. Okay, so first is your NIC. NIC card stands for network interface card. Okay. So NIC NIC stands for network interface card. It is a hardware component that allow a device like a computer, laptop, or printer to connect a network either through a cable or wireless. Okay. So support NIC is like a SIM card in your phone, just like the SIM connect your phone to the mobile network, and the NIC connect your device to a computer network, so it can send and receive the data. Okay, so this is your NIC card. Okay, now there are two types of NIC card. One is wireless, and second is your wire. Okay, so in wired NIC card, use an Ethernet cable to connect your device to the network, and it has an Ethernet port where you plug in a local area network cable. Okay. Now imagine you are in a cyber cafe or an office where your desktop computer is connecting to the internet using a local area cable. That port now that port this one is your wired NIC card. Okay. Now, what is wireless NIC card? Wireless NIC card let your device connect to a network without any cable, and it uses Wi-Fi signal to connect to the router or access point. Okay. Now think about your laptop or smartphone connected to your home Wi-Fi. That's your wireless NIC working. Okay. It's no needed cable, just Wi-Fi matching. Okay. Now mostly device today come with built-in NIC, either wired, wireless, or both. And some people also buy external NIC if their built-in NIC isn't not working. Okay, so if your PC does not have Wi-Fi, you can plug in a USB wireless NIC and NIC, and now your PC connect to Wi-Fi just like your phone. Okay, so in simple way, NIC is your device password to the network. Wired NIC uses cable. Wireless NIC use Wi-Fi, but both do the same job, keeping your device connected. Okay, so that's all about your NIC card. Now come to the next topic, that is your hub. So basically, hub is a basic network device that connect multiple computer or device in a local area network. But it is not smart. It send data to all connected device, even if only one of them actually need it. Okay. Now hub does not think. It just share the message with everyone, like forwarding a WhatsApp message to the whole group, even if it was meant for one person. Okay. Now imagine you are in classroom and one student want to pass a note to just one friend, but instead of giving it directly, he stand up and read it out loud to the entire class. That how a hub works. Every device on the network get the message, even if it is not for them. Okay. Basically, how there are three types of hub. First, active, passive, and intelligent hub. Okay, so active hub boost and clean the signal before forwarding it, act like a mini repeater. Okay, and second is passive hub. Just forward the data as is no power, no signal boost. Okay, and last is intelligence hub. Somewhat smart, can monitor traffic, but still not like a switch. Okay, so that's all about your hub. Okay. In this diagram, we see a simple network that is connecting through a hub. Okay. This one is your hub. At the center, there is a blue colored hub with multiple ports connected to the hub are PC1, PC2, PC3, and PC4, and a server. Okay. Now let's understand what the hub does. Whenever a PC say PC1, this one, send data to another device, the hub forward that data to all connected device. Okay. So even if the actual receiver is only PC3, this one, this create unnecessary traffic in the network. A hub is a physical layer device. It does not analyze the data in any way. It just blindly forward and it to all port. That's why it is considered less secure, and it also lead to more chance of data collision. Okay, so the hub does not maintain any MAC address table. It support only half duplex mode, meaning it can either send or receive data at one time, not both simultaneously. Okay, so in modern time, hub are rarely used because switches and router are smarter and more efficient. However, understanding the hub is still important because it forms the foundation of networking concept. Okay, so that was a simple explanation of hub based network. Okay, now come to the next. That is your switch. Basically, switch switch is a smart network device that contain multiple device in a local area network and send data only to the device. It's mean for not everyone like a hub. uh, Imagine you are in office. You want to tell something only to your colleague sitting on desk number 5. Now, instead of shouting it to the whole office like a hub, you walk directly to the colleague and whisper the message only to them. That's what a switch does. It delivers data only to the right device. Okay. So how it works? Every device has a MAC address, MAC media access control, a unique ID. When a device send data to the switch, check the MAC address and forward it to the correct device. Okay. Now unnecessary traffic equals not faster and safer communication. Okay. So now switch. There are two types of switch. First is unmanaged switch and second is managed switch. Okay. So that's all about your switch. Okay. Now understand this image. Okay. So in this diagram, we are looking at a simple switch based on network. At the center, there is a network switch uh, with multiple device connect labeled PCA to PCF. Okay, PCA, PCF. Okay, this one. Now let's understand how a switch works. Suppose PCA, this one, want to send a message to PCF to this. This switch first check the MAC address. Okay, this switch first check the MAC address table it maintain. Okay, it use this table to identify exactly which port PCF is connected to. Okay, it check PCF MAC address, and after that which port PCF is connected to. Okay, now instead of broadcasting the data to all device like a hub, this target communication means less traffic on the network, higher security and faster data transfer. Okay, so unlike hub switch operates at the data link layer, that is layer 2 of the OSI model, and they can filter and forward data based on MAC address. Okay, so switch also support your full duplex communication, which mean a device can send and receive data at the same time, and improving performance. Okay, so as you can see in this diagram, even though all PC are connected to the switch, only PCF receive the message intended for it, right? So that's why switch are widely used in modern network, and they are efficient, secure and smart. So that was a quick but detailed explanation of how a switch based network work. Okay, now come to the next, that is your router. So basically router is a smart network device that connect different network together, especially your local network to the internet. Okay, imagine you live in a house with many rooms. Each room has people, your phone, laptop, TV, uh, but they want to talk to someone outside the house, and they all go through one main gate. Uh, the router decide where each request should go. Like if your phone want to visit YouTube, your laptop want Google Docs. It also makes sure the reply come back to the correct device inside your house. Okay, so the router sorts everything and send them to the right place on the internet. Okay, so how many types of router are? Okay, so there are four type of router like wired, wireless router, core router, and edge router. Okay, so wire router uses Ethernet cable to connect device. Okay, and wireless router send data over Wi-Fi, and core router used by internet service provider and big companies like handle heavy data traffic. And last is edge router. It is set at the boundary of two network, like between your internet service provider and your local local network, right? So this is all about your router. Okay, so in this diagram, we are looking at a router-based network setup. At the top, we see a device level branch router with the IP address 172.16.1.1. Okay, this router is connected to a switch with IP address 172.16.1.2. Okay, and from this switch, multiple devices are connected. Okay, a server with IP address your 172.16.1.50. Okay, and oh, three client, client one, client two, client three. Client one IP 172.16.1.100. Second is 172.16.1.101, and third 172.16.1.102. Okay, now let's understand how this works. A router is a layer 3 device in this in the OSI model, which means it operate at the network layer, and its job is to route packet between different devices. In this case, the router connect this local area network to either network to either another network or the internet. Okay, so when one of the client want to communicate with an external network or your another subnet, the router handles the traffic. Okay, this one. Now this switch on the other hand is used to connect device within the same local area network. It forward traffic based on media access control, that is MAC address. Okay, so whereas the router forward based on IP address, this setup is very common in enterprise network. The router provide network routing. The switch handle internal traffic, and the server store or manage data application or services for the client. And these type of topologies is efficient, scalable, and provide proper network segmentation and security. Right. So this was a clear overview of how a router-based network operate and how all components work together. Okay. So now come to the next, that is your repeater. Okay. So repeater is a network device that boost or regenerate signal in a network so that so this data can travel longer distance without getting people lost. Okay. Suppose you are at a party talking to your friend who is far away. Your voice is getting faint. So you use a microphone and speaker to make your voice louder and clear, so your friend can hear you easily. Right. So that exactly what a repeater does in a network. It listen to a big signal and boosts it and send it further so device far apart can still communicate. Okay. Now how repeater work? Imagine receive the weak or distorted signal from one network segment and amplifier and clean the signal, right? And second is send the strong clear signal to the segment, help extend the range of the network. Okay. uh, that's all about your repeater. Now look at this image. Okay, so let's understand with this diagram. Imagine you are transmitting data over a long cable as the signal travel far, and it start to weaken. We call this signal attenuation or corruption. Okay, so in this example, we see two direction. A is right to left transmission. The signal starts off strong. Okay, this one, and as it move left, the signal become corrupted and unreadable. Okay, so but before it fully degrades, a repeater is placed. The repeater takes the weak signal, clean it, and regenerate a fresh copy of the original signal. Right. That clean signal is how ready to continue its journey. Okay. So B, this one, left to right transmission. Left to right transmission, this time the signal is already corrected from the start. Okay, so it hits the repeater, which boost and restore the signal to its original state. Right now a fresh signal is sent to the receiver. So in simple term, a repeater does not change the data, it to just strand the signal so it can travel further about without error. Okay, so repeater are commonly used in Ethernet network and long cable runs to extend the range of the signal, right? So next time you are wondering how a signal can travel long distance, the humble repeater is the hidden hero behind this. Okay, so come to the next point, that is your modem. Okay, now okay, so what is modem? Imagine you want to send a handwritten letter to your friend who lives far away, but the postal service only accept type letters, not handwritten ones. So you need someone to convert your handwritten letter into type text before sending it, right? And when your friend receive it, they need the text converted back into handwritten so they can read it easily. Okay. Uh, for example, you are like your computer sending data, and the postal services like the telephone or cable like line that only understand type text. Okay, so according to definition, a modem, short for modulator and demodulator, and it is a device that convert digital data from your computer into analog signal to send over phone or cable lines, right? Then convert incoming analog signal back into digital data your computer can understand, right? So that's all about your modem, and there are basically four types of modem. First is dial-up modem, and second DSL modem, and third is cable modem, and last one is fiber modem. Okay, so in dial-up modem, uses regular phone lines, very slow and mostly outdated now. Okay, now second is DSL modem, that is uses telephone lines but provide faster broadband internet. And third is cable modem, that is uses cable TV lines for high speed internet. And fourth last one is fiber modem, which is work with fiber optic cables offering ultra fast internet speed, right? So that's all about your modem. Okay, so at the top we have the internet cloud, this one. This is your external connection provided by your ISP. ISP stands for Internet Service Provider. And that internet connect to a cable or DSL mode. That is this one. Okay. The modem is connected to a router. This. And the router then connect to the multiple devices like your laptop, smartphone, PC, Now wireless device via Wi-Fi. Okay. So the modem job is to bring the internet into your house, and the router job is a distribute it to different device. Okay. So I hope you understand. Now what is bridge? Uh, Suppose a bridge in a city that connect to neighborhood separated by a river. Without the bridge, people in those neighborhood can't easily visit each other. But with the bridge, they can cross the river and communicate or travel back and forth seamlessly, right? In networking, a bridge works similarly. It connects two separate network segments, so device on both sides can communicate as if they were on the same network. Okay, so according to the definition, a bridge is a device that connect two or more separate local area network or network segment and forward data between them, and it help reduce traffic by dividing the network and only passing necessary data, improving overall network efficiency, right? So that's all about your bridge. And now come to the types of bridge. Okay, so there are three types of bridge. First is transparent, second is route, and last is translation. Okay, so transparent bridge it's automatically learn the network layout and forward data accordingly. Okay, and second is source route bridge, used mainly in token ring networks, forward data based on the source route information. Okay, and third is translation bridge. Okay, so connect two different types of network like Ethernet and token ring. Diagram we see a simple network setup that is connecting through a bridge. Okay, so there are two network segments shown here. One is and second is okay. So the top side and the bottom side, and they are both connected using a device called a bridge. Okay, so one is and second is okay. Now let's understand how this bridge work using two example shown on this screen. Okay, so first example is that packet from PC A to PC D. Packet A from packet A to CD. Okay. So in the first part of the diagram, PCA, this one, sending data to PCD to this PC. Okay. So both of these devices A and D are on the same network segment, right? So the bridge does not interfere. It simply lets the data flow directly because there is no need to forward it to the other segment. Okay, and this help in reducing unnecessary traffic to the other half of the network, right? And second example, packet from PCA to PCG, PCA to PCG. Okay, in this second part, PCA is now sending a packet to PCG. Here PCG uh, is in the lower segment, and which means the bridge must step in, and the bridge look at the MAC addresses and understand that PCG is not in the same segment as PCA. Okay, so it forward the packet only to the segment where PCG exists and loads to all devices. So this target forwarding help reduce data collision and improve network efficiency. Okay. Now come to the next topic. Okay, so what is gateway? Imagine you are traveling from one country to another, right? Each country speak a different language and use different rules for driving, money, and communication, right? So you need a translator or guide at the airport who understand both language and can help you navigate the new country rule smoothly. So in networking, a gateway work like that translator or guide, and it connect to different network that might use different protocols, architecture, or data format, and makes your data flow correctly between them. Okay. So according to definition, a gateway is a network device that act as a translator between two network devices. Okay, and often with different protocols, it convert data from one format to another, so that device in these different network can communicate effectively. Okay, okay. Now come to the diagram of this gateway. Okay, so in this diagram, we see a gateway connecting a local area network to a wide area network, right? So let's break it down by step by step. So on the left side, we have three computers that are part of a local area network. It's called internet network. Okay, this one. Uh, In the center, there is a red black block labeled G, which represent the gateway. This one, and this gateway connect to the internal local area network to the external network shown here as a wide area network. This one, okay. So now, what exactly does a gateway do? A gateway is like a translator or bridge between two different networks. This one, okay, that speak different language. It work at all layers of the OSI model, especially the network and application layer, and it capable of converting protocols so that communication can happen between totally different system. Okay, so suppose that if your local area network uses TCP and IP and the wide area network using another protocol like your MPLS or ATM, the gateway makes your both side can still understand each other. Okay, so how it work? So let's say one of the local area network computer want to access a website or send an email over the internet. Right. So next goes request goes through the gateway, which check it and convert it if necessary and forward it to the wide area network. Right. So when respond the gateway translate the response back into a format the LAN device can understand. Okay, so that's all about this. Now come to the next, that is access point name. Okay, imagine you want to send a letter to a friend living in a huge city, but first you need to know the exact address and the post office that will deliver. Okay, so without the correct address, your letter will not reach the right place, right? So in mobile network, the APN is like that exact address. It tells your phone where to connect to access the internet or other data service on your carrier networks, right? So APN is a configuring setting on your mobile device that identify the gateway between your cellular network like 4G, 5G, and the public internet or private network, right? So it defines how your phone connect to the internet through your uh, mobile carrier. That's all about access point name. Okay, so now come to the next access point name. In this diagram, we see how an access point help connect wireless device to a wired network. So on the left side, this side, there is a Cisco Unified Communication Manager. This one. This is used to control the managed communication system like IP, phone. Okay. So below that we see IP phone connected through a switch. Okay. This one. This show the wired network setup where devices are physically connected using cable. In the center, that is axis, and we have an access point connected to the switch. This access point act like a your wireless hub, and on the right side, we see laptop connected to the access point using Wi-Fi. Okay, this using Wi-Fi wireless. Both devices are connected to each other, and so what actually happening in this image? Okay, so the access point is bridging the gap between wired and wireless network, and it receive data from the switch and send it wirelessly to the laptop. Similarly, it receive data from laptop and forward it to the wired network via the switches. Okay, so that's all about your access point. Now come to the next, that is your server. So imagine you are at a restaurant. You sit down and place your order with a waiter. The waiter takes your order to the kitchen, and where the chef prepare your food, then the waiter brings your food back to you, right? So in this according to example, you are the client. Okay, client means the one requesting something. Okay, and second, the kitchen is the server to one fulfilling the request. Okay, and third is the waiter, which is in the network that carries the request and the food between you and the kitchens. Similarly, in computer network, a server is a powerful computer or program that provide resources, data, or service to other computer over a network. Okay, so that's all about your server. Now come to the structure of, sorry, a diagram of your server. Okay, so this diagram show a client server network architecture. A central server is connected to multiple client device like your laptop. Okay, laptop, desktop, printer, uh, and other devices. Okay. So what is happening in this image? The central device is a server. Okay, this one. Uh, this is a server, and it is the main computer that provides service, data, or resources to other device. And all the other device are client connected to the server. These all the devices are connected to the server. These clients send requests to server for data files printing or internet accessing. Okay, so the server respond to those requests. Suppose when you open a website, your computer send a request to a web server, and the server process the request and send back the website content to your browser, right? So similarly, when user want to print something, they send a request to a print server, and it forward the job to the connected printers. Okay, so this is called your server.